I really love working with AWS CloudFront because I think it's one of the best CDNs out there, especially regarding the compute capabilities on the edge. Sadly, working with it, especially if you're doing a lot with the Lambda Edge functions, is a nightmare. This is due to the fact that CloudFront will distribute all your code to all the edge locations around the globe. This can take 5 to 10 minutes, meaning every time you change a little line of code in your functions, you have to wait 5 to 10 minutes until the change becomes live and you can actually test what you've built. This means every typo you made and every little change is a massive waste of time. In this video, I'm going to show you how you can completely skip these deployment and wait cycles. We will be using LocalStack to set up a local development environment right on your laptop. This not only lets you trigger and test your Lambda functions, but also deploy them in milliseconds instead of minutes. The cool thing about LocalStack is it's not like it's a completely staged environment, but it's more or less an exact replicate of the AWS cloud. This means everything that you're developing and testing locally will be replicatable to the AWS cloud. I will show you how to set up your local environment. We will be writing simple Lambda Edge functions and how we can deploy them to our LocalStack Docker container. All of this without ever touching the AWS console. Using this workflow, you can speed up your development process immensely. Let's look at the architecture. This is how CloudFront's architecture looks like. If we look on the left, we have the browser or the user, and on the right side, we have the origin, so the destination. CloudFront sits right in the middle, distributed around the globe. With CloudFront, we have 4 specific places where we can run our custom code on the edge. First one is the viewer request. It will be hit as soon as the request hits CloudFront's edge. So the second one is the origin request, which will be invoked right before your origin server is called. After the origin server has returned a response, it will invoke your origin response Lambda function. The origin response Lambda function will then return the result to your viewer response function, which will be invoked right before the request will finally get back to the user. Generally, CloudFront has to push your code to every edge location around the globe. That's why it takes so long to deploy. When we move to LocalStack, all this CloudFront architecture will be moved into a local Docker container. This means we don't have to wait for the deployments around the globe because everything happens on our local machine. When we send a request to our local CloudFront, which is executed in our LocalStack container, LocalStack will also determine which functions are attached and also execute the code locally. The cool thing about this is LocalStack will also pass exactly the same object as AWS will. This means we will get the exact same headers and the exact same request structure. It behaves exactly like on the edge, but it will be executed on our local machine. This means we can replicate the whole request response cycle in milliseconds, including the deployment. Let's set up our local machine. The first thing we need to do is to create a LocalStack account. This can be done in a few seconds by visiting localstack.cloud. Let's click on the Get Started for Free button. I already have an account, so I can click on the Login. So let's log in. This is the window that we will see after logging in. It's the Getting Started wizard. It will help us to set up our local machine with LocalStack. The first thing we need to do is to install the LocalStack CLI. Let's copy the command and paste it to our terminal. As I've already installed LocalStack, I won't run it again, but let's see which version is installed on my local CLI. As we can see, version 4.12.0 is installed, which is the latest version right now at the end of 2025. The next thing we have to do is to set up our auth token for our local CLI. So let's copy the command again and run it in our terminal. As I've already done this, my LocalStack CLI is already connected to my account. When everything is connected properly, we can just run LocalStack start, which will start the Docker container, which is now connected to our remote account. If you see something like this, everything has started properly. There's only one thing left that we need to install. It's the Terraform local package. We can install this either via pip, like shown here, or just by also using Homebrew if you're on macOS. This simple tool will help us to run our Terraform code directly against our LocalStack container without having to configure anything else. Now let's jump into the interesting parts of this video, the actual code. For this, I've set up a very simple example repository with a CloudFront distribution and just a single edge function. Actually, the 𝗧𝗶𝗺𝗲𝗀 function. The only thing the function does is returning an additional header x minus lambda. As this is only for showcase purposes, just to show you how fast LocalStack actually is. Everything is set up via Terraform, so we got a CloudFront distribution, our edge function, some IAM permissions, and that's basically it. One thing that I forgot to mention was that we explicitly need to enable the Lambda Edge functionality because it's currently in the beta phase. This means we have to start our LocalStack container once again. We need to pass the CloudFront _ lambda _ edge parameter to our local container, like you can see in the terminal. After that, our LocalStack container will start again and we are able to use Lambda Edge. So it has been successfully started. Now we can switch into our Terraform code. Let's run tf-local init to install all of our providers, which will take a few seconds. As we can see here, we have the green dot on our localstack.cloud environment, which means our local Docker container is connected to the console. When we click on the Overview tab, we can see we have no resources created, but this should change now. So let's get back to the terminal. Terraform is ready, so we can use the tf-local apply command to actually deploy our resources into our container. Let's do exactly that. As we saw, the plan just took milliseconds to calculate because we're not actually talking to the AWS API, but just to our local Docker container. Now tf-local will just continue creating our resources in our container. As you can see, instead of like 10 minutes, we just took 30 seconds to create and publish our Lambda functions, create our role, and create the CloudFront distribution. And we can immediately use it. LocalStack will also print us the CloudFront URL, which will always be a subdomain for localhost.localstack.cloud. What is important here, you definitely need to set your DNS resolver to either the one by Cloudflare, so 1.1.1.1, or the one from Google, so 8.8.8.8, because their DNS resolvers, the localhost.localstack.cloud domain is actually configured to resolve to localhost. So let's now jump back to the web console and refresh the board. And we can see our resources are successfully created. We can see the CloudFront distribution is here. The EAM role is there for our edge function, and we can see the edge function is also there. If we switch to the resource browser, we can also select CloudFront and then directly click on the distribution we've created. In this overview, we can see all the details. So for example, we will find our Lambda Edge function, which we can see. It's the first version that was published. So it's :1. I've already copied the URL that we got from CloudFront, so we can just use a simple curl -i https and our URL to actually invoke our distribution. And hopefully we can see our custom response header that will be attached by our viewer response function. And as we can see, it's x minus lambda, hello from Lambda, so everything works perfectly fine. It's a quite nice development experience if you compare this with the actual AWS cloud, where we have to wait at least 10 minutes for everything to deploy. To wrap things up, we took a workflow that takes at least 10 to 15 minutes into a workflow that just takes seconds. With LocalStack, we replicated our AWS cloud into a local container, which speed up our development cycle a lot. The best thing is we can still use our Terraform code by using tf-local without any additional setup. With this setup, we no longer have to wait until AWS pushes our code to all the edge locations around the globe, because we have a local setup that works equally well. Once our logic is ready, we can deploy it to our staging or production environments by just switching to the actual Terraform command instead of tflocal. If you want to try this out yourself, the repository is linked in the description and you can just check it out on your local machine. This setup will definitely save you a lot of time if you're working a lot with CloudFront and the Lambda Edge functions. As CloudFront is used very commonly, you will likely stumble upon the service once in a while. If you're just starting out with AWS, or you may be just starting out with CloudFront, we have a huge infographic about CloudFront which will explain all the necessary features and details you should be aware of. You can also find the link to the infographic in our description. Big thanks for watching this video, and I'm happy to receive comments about your LocalStack experience.